Hello, welcome to a webinar presented to you by Cheeba Cannabis Academy from Johannesburg, South Africa, as well as House of Extractions, also from Johannesburg, South Africa. Tonight we're going to be talking about ethanol extraction. It's one of the popular methods of extracting cannabinoids from cannabis, as well as other things, but we're going to be focusing on all from home extraction, all the way up to industrial, because you can extract via using ethanol at home, but when it gets industrial, it gets very complicated. There's lots of big pieces of machinery, which we'll be showcasing as we go through. I've got some amazing guests tonight, so we're going to talk a lot of deep technical information. If you're new to extraction, you will definitely learn some stuff. If you know a bit about extraction, we will go deep, so it'll cover all kinds of different areas. But thanks for being here. I look forward to being with you for the next 60 minutes. I'm going to bring my guests in, and they're going to introduce themselves. They are from all over the world. So let's start off. Hello, guys. Welcome. Thanks for being here. Who are we missing? There we go. Hi. Right. Let's welcome to the webinar. We really appreciate your time. We do these webinars on a regular basis to try and share knowledge. At the end of the day, the best way to move this industry forward is to share knowledge and not keep it all to ourselves. So thanks for being here. I know we've got people from all across the world. Storm, let's start with you. Storm, House of Extractions, good friend of ours. We're co-presenting this with him. She has on our facility and our campus in Johannesburg, has just moved in. So we're very happy to have him in there, so that we can exploit him and get our students in and get them messy and learn how to do things. Storm, just tell us who you are, where you're from, and just a bit about House of Extractions quickly.
Awesome. Thanks so much, Trent. And yeah, no, it's an absolute pleasure to be in on the campus these days. I am the founder, director of the House of Extractions. We provide oil extraction solutions to growers in the free sort of unlicensed market, across the board, from solventless through to solvent-based extractions. We try to provide our clients with the best possible solution to their desired outcome.
Great, thanks, Storm. Doug, nice shirt.
Thank you. My name is Doug Cody. I am in Salem, Oregon. I'm retired, and I've spent the last 3.5 years making all sorts of mistakes in trying to sort through all the possible combinations to make alcohol extraction work very fast, efficiently. And with these results, you can hit 80% cannabinoids within a couple hours rather than a couple days in extracting your oil. So I'll be presenting some things as we go through the schedule, and I will hand it back.
Great, thanks, Doug. I know you've got a lot of deep experience, so thanks for being here. Much appreciated. Let's go to Rui. Rui, sorry, did I get that right?
Yes, that's right. That's
perfect. Right. Over to you.
So my name is Rui. I come from Paralab Green. We are based in Portugal, but we are operating more or less in all Europe, Israel, North Africa, and Latin America. We are a one-stop shop in terms of post-harvest extraction equipment, although we have been always on extraction and came later to the post-harvest. We offer complete solutions for solventless, ethanol, CO2, and hydrocarbon extractions. We have been operating mainly on the licensed market. Initially, mainly THC-based, nowadays also growing to the CBD market.
Great, and you get to play with lots of big toys, yeah?
Big toys is our field, yeah.
Great, thanks so much for being here. Mozella, you're going to need to unmute yourself, and then just let us know who you are and where you are and what you do.
Thank you very much for having me. I'm Mosele Tsomani from MG Health. I'm working as a production manager. And in terms of cannabis extraction, we have done very extensive studies with CO2 machine, quite big, which did well. And we also had to move to cold ethanol extraction. So we have, on CO2 machine, we have done extraction of CBD and THC, and then on cold ethanol extraction, we have done all sorts of strains that we have. We have about 6-7 strains. So we have done all of that.
Great. And just for those of you who don't know, MG Health is in the mountains in Lesotho, one of the oldest sort of legal medical cannabis farms there. So thank you so much for joining us.
And another question could be, where are we? I think the most important thing to highlight is, where is MG Health in terms of, where is MG Health and in terms of a cold ethanol extraction. MG Health at this point has absolutely moved from small scales. It has moved totally from the kitchens to the large scales. We're exporting to countries like Germany, Australia, and UK. And most importantly, our system is GMP compliant and certified.
Great. Thanks so much for that. So there will be people who obviously know what ethanol extraction is, and there will be some people who don't know much about it. So I want to start off by an introduction and an overview of what ethanol extraction actually is. So maybe, Storm, we can hand it over to you, and then we'll do the rounds. Oh, I think we've lost Storm. There we go, Storm.
Cool.
Over to you.
Thank you so much, Trenton. Cool. So basically, ethanol extraction makes use of a solvent, namely ethanol. And there are very many similar solvents out there that are ethanol-based or very similar in structure to ethanol, like isopropyl alcohol. And these solvents are all generally, they are polar solvents. So they interact with the polar compounds in the plant material. So they are able to pull out certain compounds that other solvents that are non-polar, like hydrocarbons, butane, propane, are not able to pull out. With that, there's a lot of extra contaminants that can be pulled out using ethanol, and so there are certain techniques that we like to implement. And when you have access to the bigger machines, they can help with the winterizing and the filtration and that sort of thing. But on a home scale, there are a few techniques that can be used to help mitigate the level of contaminants that come through in our end result extract. I know Doug Cody is quite experienced in the home side of the ethanol extraction, and I was really looking forward to picking his brain a little bit. Doug, I hope you don't mind.
Sure, absolutely. That'd be great.
So
Great.
what do you see as the most...
Was that to me?
Perfect.
Say that again. You dropped out the last couple of words.
Yes.
Say that again.
Sorry about that. Doug, what do you see as the most significant benefits of ethanol extraction for small scale users versus industrial operations compared to other solvents?
Alcohol extraction is very simple. You can do it with minimal equipment. You don't need a lot of experience, but you do need caution. This you'll be using it or distilling alcohol with heat, and therefore you may have problems, safety issues around those evaporated solvents. So that's what we want to take a look at in the safety portion of the talk. But other than that, it's very simple. Now, I have advanced the skill with a process that has more handling. So you end up moving the material through the process manually, so you can have transfer losses. So you have to be careful about how you handle the material. And that's all mechanical. This doesn't require a lot of science, but it does take understanding the science behind each step. Later on, Ree will show us what a solvent extraction is at the industrial level using huge, what are called skids. And this skid will have equipment for each stage. And I want you to take a look at the name of each stage, because those stages relate directly back to the home extraction. So what we talk about in home, Ree is going to show us at the industrial level. Okay, but it's all about safety, and it's all about understanding what each step is doing. Okay.
I would just like to know Rui, how big is ethanol extraction compared to other extraction methods in the cannabis industry?
Well, actually, you have for all sizes from these home systems. But small productions, they can start as small as half a kilo, 500 grams of flour per run. And in simpler systems, we call them tea bags. So you simply soak and wait to allow time for cannabinoids and terpenes to be dissolved and to permeate out of the flour. You are always looking to 45 minutes, 1 hour, even a little bit more if you want high efficiencies. But you have these small systems, and then they can go to several cubic meters. One point to take in consideration typically is that for each kilo of ethanol, for each kilo of material of milled flour, you will be using around 10 liters of ethanol.
Wow.
So when you have a 10 cubic meters extraction system, you have these large systems, you are processing each time around 1 ton of material. So it's highly scalable. Is one of the techniques that when you try in small scales, you can, without many errors and without many adaptations, really scale up directly. There are no surprises. The main issues is what is the technique behind or the technology, because you have, I mentioned the tea bag or soaking. You simply soak material and wait. You can make the process more efficient and faster by creating some kind of agitation or recirculation that somehow puts in, forces the ethanol through the material. And you have then most advanced systems using centrifugation, because here we are talking about high-speed centrifuges in which the flour material, mill material, is inside bags. These bags are in rotors, centrifugal rotors that go between 1,000 to 2,000 rotations per minute, and ethanol is injected in this system, and in center and centrifugal forces will pull the ethanol through the material out of centrifuge, and this is like getting in, getting out. For manufacturers, say 10 to 15 minutes. In reality, if we want higher efficiencies, we will be minimum 20 minutes. Nevertheless, it's 2, 3, 4 times faster than any other method of, and also in terms of the efficiency, so in terms of the yields of cannabinoids that you are getting is higher, but most especially because it's like in your washing machine at home. With high centrifugation, at the end, the clothes are almost dry. They have a very small content of water. Here, in ethanol extraction, at the end of the extraction cycle using a centrifuge, you have 1, 2, 3% max of ethanol on the residual biomass, which is excellent, because this is one of the main issues working with other techniques. Doesn't matter if at home or in industrial, so if it is the soaking on or the gestation tanks, is that after doing a fast filtration of recovery of the ethanol or the tincture of the ethanol with cannabinoids, you are left with a biomass, soaked biomass, that may have between 10-20% of ethanol content. So you have there 10-20% of your cannabinoids. And if you are, and these extractions, as Doug already mentioned, they are done at low temperatures, -20 and below. So if you take this out to put in an external press, is warming up. So you are now dissolving waxes and many other compounds that you don't want. Waxes and chlorophylls are the main ones. So you are redissolving. You can recover, so this 20% in a press, exterior press, but it's a really bad tincture that you have there that will get you a very, very bad oil. So it actually is useless if you are looking for high quality extracts. So my recommendation is centrifuges. In industrial processes, centrifuges. No soaking, no stirring vessels. You should look for centrifuges. It's more efficient. That's what also gets you the higher quality extract. And then we can talk later on the downstream processes, that everything else is easier from there on.
Yeah, well, I want to go to the process in a second, but just to clarify, how big is ethanol extraction compared to other extraction methods like critical CO2? How much market share does it have? How popular is it?
Okay, now it depends on markets. If you are United States recreational or in the hemp market, is the main technique. Nowadays, let's say that BHO is getting a big chunk of this market, and we start seeing solventless going big to this. But in the past, ethanol has been de facto the main extraction technique. Let's say on the past 10 years, it has been the main extraction technique. Recreational or pseudo-medical, I say pseudo-medical because real medical is a very small market in North America. In Europe, with the advent of medical cannabis is different. Yes, some initial companies went with ethanol, a lot because they were concerned about UGMP compliance, and there was a German manufacturer offering this. But this was basically bag and with lots of problems that comes with this and evaporation techniques altogether in this kit. So now the future is CO2. In medical cannabis in Europe, CO2 is taking place, and even solventless is also taking big attention to the medical market. So ethanol may still rules, but is losing traction, a lot because of the quality of the extracts. You do not get the same quality of extract, especially when terpenes profile is an issue, and we can discuss this. And then because of running costs. So CapEx investment is slightly lower, but the running costs are higher. And when we go to medical applications, in which you cannot reuse the ethanol, although you may recover 95% of ethanol after each run, under UGMP, you cannot keep use it. Typically, you are targeting 5 runs, and then you have to replace it. This is quite expensive. So is one of the reasons that ethanol for medical cannabis is not so well seen, a lot because of running costs. The other thing that I mentioned, terpenes. So ethanol is a very strong solvent, and you cannot fractionate like you can do with BHO or you can do it with CO2. So when you extract cannabinoids, but you also extract terpenes. And when you go downstream processes, starting with evaporation, everything that is volatile is not only the ethanol, is also the terpenes. So part of the terpenes will be lost during the evaporation. So to recover the ethanol, so to separate ethanol from the cannabis oil. But the really massive loss of terpenes comes with the carboxylation. If you have terpenes on your oil during the carboxylation, you will lose a huge portion. So when people say that they have full spectrum oil coming out of ethanol extraction, this is wishful thinking, because full spectrum oil is an oil in which you have a chemistry on extract similar to the flower, meaning that the ratio between total cannabinoids and total terpenes in the extract are very similar to the ones that you find in flower. If you are losing terpenes in all the process, you are losing the ratio of terpenes to cannabinoids decreases a lot, so it's not similar to the flower. Saying that you have a full spectrum oil coming out of ethanol on traditional way, it's not correct. It's marketing, it's wishful thinking, but not correct. There are ways to overcome this by drying, doing a decarboxylation on flour in vacuum ovens with terpene traps. The point was that in small scales, this is easy to do. When you start scaling up and going to huge quantities that are common in ethanol extraction, it's difficult to process, to decarb plant when you are talking about hundreds or tons per day.
Yeah.
Technically, it's possible. Economically, and making it in a practical way is not that easy.
Okay, thanks for that. Storm, I'm going to come to you, and then I'm going to go to Mosile. I just want to show a few pictures of sort of industrial applications, because this is how sort of big these machines can be. But let's just rewind it back a bit, Storm, and just talk about how people extract using ethanol at home. Just unpack that a bit.
Sure thing. Yeah. What we like to do here at the House of Extractions is a quick wash ethanol treatment, QET. And we make use of a technique that's come across on the internet. It's known as bucket tech. So with the use of dry ice, we are able to bring the temperature of the solvent right down to -40 or below. And we are able to, in using bubble hash washing bags, create that tea bag that Rui was talking about. And I hope I said that correctly. And we can submerge the biomass into the now very, very cold solvent, and we can then remove it. And by pre-chilling the solvent, we are able to mitigate the amount of undesirable waxes and lipids that we don't want in our in our end extract. And by bringing the temperature down, there will be some waxes and lipids that are brought out, and we actually run it through our bubble hash washing bags. The finest mesh micron on our set is 25 micron, and that actually catches quite a large portion of the waxes just at that micron level, without the need to use something like a Bachner funnel and filter media like diatomaceous earth or activated carbon, which you can use. We can use that. The activated carbon will help polish up the extract on the way out, brightening up the color. But again, then you start to remove more volatiles out of that extract with the use of activated carbon or bentonite clay. So it really does depend on what the end application is. But we are a big fan of Bucket Tech. Doug, I know you've done quite a lot of extensive work on home extraction. Are you familiar with Bucket Tech?
Oh, yes. I have gone through many experiments using dry ice. So I use dry ice in a different place. You're using it up front where you chill your entire volume of alcohol, then you wash your plant, okay? And what the temperature gives you is the ability to not dissolve waxes. You leave most of the waxes behind, but it also does not penetrate the plant, so you avoid the chlorophyll. So in chilling your alcohol up front, you're accomplishing two things. In my process, which I will show you later, is derived from the cooking oil industry, and we have in the cooking oil industry actually has this process in a different order. It's really interesting. Winterization is done about the fifth step rather than up front, which is Quet is doing with the frozen alcohol. So there's actually a faster path to the end product using the cooking oil industry's approach. So with Quet, yeah, you want to freeze your alcohol and actually freeze your plant. I'm a little dubious about that because when you freeze it, you make it water, and ice will form boundaries, and you don't want that on your plant, because then you're blocking the alcohol from having access. Okay, so you have to be careful with that. So let's continue. I think I've spoken enough. Did I answer your question?
Yeah, no, definitely.
Thanks, Doug. We're going to come to Musile. Musile, this is a picture of what you guys are using at the moment in Lesotho. Maybe talk us a bit about the journey. Why did you decide to go ethanol? And maybe just unpack some of the challenges you might have had in getting it installed, etc., and where you're at with it.
Okay, I can't see the picture.
You'll have to talk. It'll come on, but it'll go off. So we don't need to go into detail, but I just wanted to showcase what it looks like.
Before we can touch on on my picture, I just have a few questions for Roy. If I pronounced it right, Roy.
Yes.
Roy.
Yes, it's right.
Okay, so Roy, I have questions for you. I realize you have extensive knowledge in CO2 extraction and also cold ethanol extraction, which is beautiful. So in terms of CO2 extraction, what purity did you get?
Well, it's a good question. It depends on the quality of your extractor. If you have the most advanced CO2 extractors, and most advanced CO2 extractors, we cannot even say that they are supercritical because they operate in different conditions. Although they can do also supercritical, the best is not operating supercritical. They are getting always between 80 to 87% potency oils. And it doesn't matter how potent is the biomass flour that you put in. So imagine that you are starting with a hemp biomass, so not even flowers, like flowers, leaves, branches, everything shredded, you still get close to 80% potency. If you put very high quality 20% potency flour, you will get around 85, 87% potency. What is the difference is that if you feed very high potent material, you get high quantities of oil. If you are starting with low quality material, so these 2% shredded biomass from hemp, you get very small quantities, but you manage to get high quality. This is with new, most advanced CO2 extractors in the market. Actually, there is only one brand doing that because they are patenting it. If you use general supercritical, then you have a relation between quality of material and oil. So if you start with this very bad 2-3% biomass, you end up with 40 something percent oil. If you go to 5% hemp, you will get 50%, 50 something. If you go to 10%, you start getting on 60% potency extracts. If you go to 15, 70%, and then if you are at 20% flour, then you are again at the 80%. So you do not see so big differences in high quality flour between supercritical classical extraction and most new advanced method of Soncio. It's just that for the same volume of extract with these new technologies, you get 3 to 5 times higher throughputs, maintaining extremely high quality. Something that in the past with classical supercritical fluid extraction, speed and quality, they don't go together. Either you are targeting high quality extracts and you extract at low pressures slowly, so you get a good extract, but it takes a long time, or you step the pedal, you increase the pressures, and it will be very fast extraction, but then the extract is not good, and not even 3 winterization cycles will save the extract to get premium extracts. So supercritical fluid extraction, you have to go slow to get high quality. New CO2 extraction technologies, you can have speed and quality. With ethanol, you always have speed, and quality, as I mentioned, can be good. It can be actually quite good if we are not concerned about terpenes. There are people that are targeting extracts without terpenes. Then okay. If terpenes is an issue, then ethanol may not be the best option. So I'm not against ethanol. No, we just, each technique has their advantages. Ethanol for going to distillates that we will not be adding after terpenes, let's say for vapes, or if we are targeting isolates, it's a good option, and it's an excellent option if you are outside the GMP arena where you do not have to be recycling or discarding. It's the right word. You are not discarding so often the ethanol. It's a very good option
Just because you're coming at it from a slightly different angle, I just want to know what made you guys decide to go with ethanol extraction, and how was the journey? Because obviously you are a farm and you are doing post-harvest processing on the farm. How have you found adapting the technology and actually utilizing it?
Okay, so from what Roy just said, it seems like we didn't have the latest of CO2 machine, honestly. What we had was basic compared to what he has just explained. So challenges that we had, it's a very good technology, I need to say, but we ran at high pressure, obviously. We're aiming at supplying our clients, and speed was everything. So selectivity wasn't good. We ended up with about 50 to 60% purity, which wasn't so good. And then in the end, we still had to do winterization. And that's when our engineering team decided, okay, we still have to do winterization. Why don't we just go ahead and just do cold ethanol extraction. So they came up with this simple setup for cold ethanol. It's very simple because it passes cleaning validation. It's easy for our people to run. Remember, we are located in the middle of nowhere, so it's very important that everything is very simple. And another thing is we are able to use ethanol still within 99% purity for about, he said 5, I'll argue and say 6, and still get the consistent results. So that's how we ended up opting for cold ethanol.
So,
and in terms of safety, what did we do in terms of safety? You don't want moving parts where there is ethanol. So our crate engineering team decided, okay, instead of pushing out material, say mixture of ethanol and crude in a case where you have already extracted, we decided we're going to use nitrogen. We use nitrogen for most of the things in the facility because it's quite inert. And we also have our floor effed, and most of the equipment of our cold ethanol setup is effed. Another thing that we aim at. Remember what I said? I said in the beginning, I said MG Health sort of prides itself for having GMP, EU GMP, which is what everyone else wants. So our setup is GMP compliant. One, you have to validate that process. So in a case where we had, sorry. So in a case where with CO2, obviously we had to mill it. We had to mill our cannabis. But you also realize that trichomes are just above your leaves. You milling it doesn't make a huge difference in terms of efficiency. You don't liberate more trichomes. They are just on the surface. And also, you don't have to have tea bags, like Roy has explained. You just put in your material in our 450 liters. It extracts well. We don't run into high operational challenges of finding ourselves having particles that are closing the pipeline. So there's a lot of work that we have to put in deciding how we want to run this. Easy to clean for us, easy to operate, and no additional steps. For us to do CO2, our basic CO2, and then later having to winterize, you realize we had to validate 2 processes. We also had to mill. That is more validation. And honestly, our team's aim was always to get GMP certification.
Yeah, I see. Just two comments there. So milling, it will always speed up the process. It's not absolutely necessary. It's just because as you have smaller particles, the mass transfer happens. Extraction is about mass transfer. Smaller the particles, the faster is the process. But there is another thing. So for the same extraction vessel, you can put far more material, so you can process more each time. That's one of the main reasons. It doesn't matter if it is CO2 or ethanol. If it is milled, you can process far more. Let's say the density of flowers, well-packaged flowers, if they are not milled, is something like 60 grams to 80 grams per liter. If you are milling, if you mill material, I'm not talking about very fine milling. That's a mistake because you blast lots of cellular membranes and you are exposing nucleotic fluid, and so the extracts are really less clean. But if you make just as small as is optimizes for each technique, for ethanol typically is around 6 millimeters particle average size. For CO2, it will be between 1-2 millimeters, the ideal particle size. So you are increasing a lot your extraction capacity by milling. Now, regarding CO2, it is true that we have to go through winterization. So we are having ethanol at the end. The point is that in CO2, if you don't go immediately to the high pressures, if you do a subcritical steps. So if you are operating initially of pressures and temperatures that the liquid, the CO2, is not yet in supercritical state, you can extract only the terpenes. So you take terpenes and you reserve them, you let them separated, so that then you follow. So you take the terpenes out, and now you follow, and this fraction with terpenes will come without waxes, lipids, chlorophylls. So then you follow to the high pressures, and it can be slightly high pressure or very high pressure. This goes with time and also with your extract. So if your crude oil will have lots of waxes and lipids or just a few, and other polar compounds also, more pressure, more polar compounds. But let's say when you go to cannabinoids and get crude oil, and then you will enterize the crude oil. But now when you enterize crude oil and you are going through then filtration and then evaporation and then decarboxylation, you are doing this without terpenes present because they are there waiting. And so when you finish this and you have a cannabinoids oil, if you add now the terpenes, you have now a full spectrum oil. That's the advantage of CO2, is this fractionation capability that is very easy to apply for the terpenes. But it's true, it requires more work, more specialized people. But once you define the conditions, it's very consistent. If you mill to the right side consistently every time, if you put the same amounts, if you set same pressure, same flows, the result will be consistent run after run. So once the team is trained, it runs smoothly. But initially, yeah, there is a longer learning curve. And this is basically what I want to sell. But ethanol, it's an option. And we have many customers using ethanol. It's the big issue for me is just terpenes. Is terpenes critical? Yes, ethanol may not be the best. Terpenes are not critical. Ethanol is a good option.
Thanks. I want to just talk the process through, because I know we've kind of jumped around, but for some people who actually don't know and understand what that process is, Doug, maybe you could kind of just talk us through each section. So this image kind of shows, chilling, extraction, evaporation. You could just talk us through that process.
Okay, this is basically a QET workflow that as soon as that image comes back up, starting from the left, going to the right. So number one, we have chilling at the industrial level, using dry ice and also industrial chillers. You can get down to 50 to 60 degrees negative Fahrenheit, negative 50 degrees Fahrenheit, better way to say that. And so that is advantage. It has the advantage of pulling just more of the cannabinoids and leaving the waxes and lipids behind. Okay, the image is gone. Then there is the extraction, and what Ray was saying is that using a vacuum extraction allows you to maintain the terpenes, but a heat-based extraction, well, I'm getting ahead of myself. I mean distilling. The extraction is where you mix the alcohol and the flour together and you wash out the cannabinoids. Then you go to the distillation, which I was talking about, where you can have either a vacuum system to keep the temperatures low to maintain the terpenes, or you can do it with heat, which is typically done in the house, at home. And that is where you lose your terpenes, okay? Terpenes may or may not be important to you. The terpenes do not bind to the cannabinoids receptors of CB1, CB2. The terpenes only influence your perception of the material that you have taken in, but they do not add to the medical advantage of cannabinoids that talk to the sensors. So terpenes are important to people. So in my process, I lose terpenes because my process is very much like Rick Simpson's making oil. where he uses heat. So I do blow off the terpenes, but I have very high quality cannabinoids oil, upwards of 80%. Okay, so in distillation, you recover your alcohol. You boil it off, you recover it with essentially moonshine still technology. Okay, you're recondensing the vapors back to liquid, and that's all there is to it. You can use moonshine still at home for that. And then you have the final reduction. Let's see, where's that image?
Let's put that up again. Yeah, there you go.
Okay. So the evaporation and the distillation, they're broken apart here for the industrial specialization, because they can subdivide down the distillation into different fractions, if you will, so that you can do something like boil off the terpenes at a lower temperature, raise the temperature, and then boil off more of the solvents, and then leaving the cannabinoids. And then you finally come to a point where you have your final oil. But that's still, in the solvent world, still needs to be cleaned up. Even in the CO2 world and BHO, butane systems, they still need to be clarified for the next step. And actually, here in the States, butane is the favorite system for that, because butane is the least polar of the gas solvents, and therefore it actually extracts the cannabinoids and without more of the plant material. But it still needs to be cleaned up. So when you have the basic extraction of solvents or CO2 or butane, you go from 0 to about 80%. Ray is saying that he can get up to 87%, and that's really, really good, because you want to think about this, the 80-20 rule. 80% is easy, the last 20% is really, really hard, okay? And that's where Ray's system of spraying the cold alcohol and using centrifugal forces are trying to get that last 20% of the cannabinoids out of the plant material. So that's an optimization at the industrial level we don't have at home. Okay, so what we have at home is being able to wash a plant in solvent and either ethanol, or isopropyl, or even acetone. So we don't have the advantage of gas at home. That's a much higher level, taking trained experience. You need, here in the States, you have to be certified as a technician to handle those things, and your systems have to be certified. So they're not home-based systems. And you don't want to be doing open blasting of BHO at home, or else you'll blow up your house. And that's very common on the yearly basis. We have several events of that in Oregon. Okay.
Yeah. Absolutely. Thanks. We're just going to take 2 seconds out. So we do give away courses on this. We have a course that is actually being run by House of Extraction in partnership with Cheeba Cannabis Academy, and that starts in a few weeks' time. So we have a winner, one of the people who are on this webinar at the moment, Kathy Millen. You have won that course. Well done. In a few weeks. If you didn't win the course, we do have a discount code which you can use at checkout for that ethanol extraction course that is run by the House of Extractions and Cheeba Cannabis Academy. Extraction 20 at checkout. CheebaAfrica.com is where you'll find that. Guys, we've got 15 minutes. Storm, let's talk about safety practices and making sure we keep things nice and clean and safe. And what are some of the things that people should be keeping in mind at home and industrially?
Yeah, no, that's very important. You know, as Doug mentioned earlier, we're working with ethanol. It's relatively safe until you start to evaporate that ethanol out of your solution. Then you're working with a lot of ethanol vapor, which is highly flammable. So you want to work in a very highly or very well ventilated area. and you want to have certain emergency protocols in place. You want to make sure you're not close to any heating elements or open flames or anything along those lines. And I think it's also very important to take into account the nature of ethanol when it comes into contact with human skin. It can be quite corrosive, especially the really pure stuff. So you need to wear safety gloves and coats, and sometimes goggles. If you get it in your eye, it's a nightmare. And just in terms of cleanliness and sanitary, we are, in the end of the day, making medicine for people, especially on the larger scale industrial size EU GMP facilities. I'm sure you guys are very accustomed to wearing hair nets and masks and safety goggles and all that sort of PPE. I think is very, very important and often gets overlooked when people are doing this at home. But I think it is very, very, very important. I do just want to touch on, we've spoken a lot about terpenes. And I think it's important to note that if you are moving, like you guys are saying, terpenes may or may not be important depending on what your desired end result is. For example, if you're moving it forward into distillation, you don't really necessarily need the terpenes present. And in fact, you can improve your process by volatilizing your terpenes out of your crude extract, and then you'll get a better return on your distillation step, as opposed to if you're distilling a crude extract that's got terpenes in it. Sorry, I just wanted to chime in there. We've been mentioning terpenes quite a lot. But back onto the health and safety, I think it's very, very important to note how you store your ethanol. It's highly flammable, especially when it's the 99% pure stuff. You got to keep it in sealed containers in a cool environment. You don't want it in full sunlight where it can, even if it's not going to explode with from flames. You don't want a pressure buildup in any containers that may be sitting in the sun and they're sealed and the ethanol is heating up and starting to evaporate inside the container. And then you can have a pressure buildup and an explosion that way. Mosele, I was wondering, do you have anything, with your expertise in an EU GMP facility? I would imagine you have health and safety precautions around every corner. Would you care to enlighten us a little bit?
Yeah, though that safety of medicine comes first, comes before safety of people, right? But what we do is we have to wear anti-static shoes. But firstly, during construction, the most important thing, the floor should be effed. The floor should be effed. The equipment should also be effed. We have checks that we do before we run any batch to check that this is nice, this is well connected, the effing is still intact. That's what we check. We always have to wear gowns because we're GMP, obviously. So we wear gowns, anti-static shoes, no shoe covers because we don't want to create any friction and end up having any sparks. Like I've said, we also try not to use a lot of moving parts. So we use nitrogen to pressure our vessels in order to transfer from one vessel to another. And everything else that you have mentioned, we also do within our facility.
So I have two more questions. Maybe we could just go around the room in the next 10 minutes. I'd like to know how we ensure consistency and purity. And then I'd also just like to unpack the importance of testing to make sure there's no residual solutions left in the product. So I don't know if everyone wants to jump in and answer for consistency and purity and then testing. If we could start with, who wants to start with that?
I want to do it.
Let's start with you.
Okay, testing in our facility, everything before you get into any process, you have to test. There's testing QC have to test and get the material released for processing. So we have to test for CN, test for all sorts of micro, because you also don't want to contaminate your equipment. But lucky for us in terms of cold ethanol extraction, I think Hoy, I've pronounced it right, Hoy had said that ethanol, one of the merits of ethanol is the fact that it's able to decontaminate the product. So in as much as you know that it has potential to decontaminate the product, you have to test for all sorts of micro. You don't want to introduce any form of contamination. And your parameters for consistency. Parameters should be consistent for all the runs. This is why we first have to start first with R&D, pilot batches, and then most importantly, validation. Do at least 3 batches to validate all the parameters and make sure that you're able to get the same results over and over. And then in the process, you do validation of the process, cleaning validation, and also validation of the product to see that you're able to get the end product as they are. And even before you can release into the next processing stage, which is formulation, or release into market if you decide to sell it as an extract, you still need to test all those things that I've stated. So testing is everything if you're dealing with medicine.
Great, thanks for that, Mosile. Anyone else want to add to that? Consistency, purity testing?
I would like to make some comments here. So, Moselle, the first thing, when I mentioned about contaminations, I was not thinking about these chemical contaminations, the typical contaminations, the microbiologic or molds, the aflatoxins, the heavy metals, and pesticides. I was mentioned about the chlorophylls, oxys, and lipids that are contaminants, considered unwanted materials or contaminants to a good one. That's what I'm saying. Now, talking about microbiological contamination, it is true, and especially for people doing this at home, one word of advice. We are working with ethanol, and so yes, bacteria, microbes, molds, they will go away, they will die using ethanol extraction. Actually, with some others, but with ethanol, no one doubts, ethanol will kill everything. Just one word of caution. When you are extracting material that has high content of mold, what is the problem? Molds, as in their metabolism, produce aflatoxins. So that is a very serious contaminant. Aflatoxin, especially aflatoxin B, is very, very toxic. So when you are doing extraction, doesn't matter if it is ethanol or whatever, but ethanol, people think, oh, I'm killing everything, so what's the problem? The problem is that, especially with mold contamination, if it has lots of mold, you will most certainly also have high levels of aflatoxins, and you are killing the mold, but you are keeping the aflatoxins, you are extracting, you are concentrating the aflatoxins, and you may get an extract that is highly toxic. Caution, at home, don't play with quality of material you'll be extracting, because it's as important to extracting as to smoke. You need to have good material, safe material. Mold, it's an issue, doesn't matter if to smoke or for extracting. Don't use material contaminated with mold in extraction. Aflatoxins will go to the extract, okay?
That's interesting, because a lot of people think you can solve contaminant issues in the extraction process. So that's great. That's great advice there. Doug, do you have anything you want to add there?
Yes, as I'm typing away, answering the question. Let's see, we were talking about quality in testing, okay? For quality for home, because we're strictly dealing with a solvent extraction, all you can really do is wash your plant and then boil away the solvent. But with my process, by introducing a little bit of distilled water in the distillation step, you end up actually creating an emulsion that carries away most of the contaminants. Because actually the alcohols are very non-polar. They tend to be towards the non-polar end of polarity, but they're not nearly as non-polar as gases. Okay, so they're considered a polar solvent, but technically they are non-polar because the oils are non-polar, the cannabinoids. This is why water and oil do not mix. Water is the most polar substance in the world, solvent, and alcohols are and fats, the oils are non-polar. So you use a non-polar solvent to dissolve a non-polar item, in this case, the cannabinoids. Okay, so you take that, and what I do with the distilled waters, when you distill away, it actually creates a slight emulsion that carries away the polar and semi-polar, and that's really crucial, compounds, leaving you with oils. So I'm hitting almost 80% total cannabinoids on every run by using a little bit of water. And what that does is I now boil away the alcohol. I have my little bit of oil. I redissolve that in alcohol. Now I can winterize. The wax has actually survived distillation, so I use a whole lot less alcohol and very small temperatures. You don't need sub-zero temperatures to now winterize. Because you've removed all the polar and semi-polar compounds, you now have strictly lipids. And lipids in the alcohol, the fats or the waxes will now crystallize. Before, when you first did your wash in alcohol, you have the whole matrix of polar, semi-polar, and non-polar cannabinoids all mixed together, and the waxes cannot freeze at their freezing temperature. You look at the melting point of waxes, and it's actually above 0 Fahrenheit, negative 20 Celsius. So why doesn't it freeze? It's because of all the other compounds in the matrix. So by distilling in water, you can now have a really fine cannabinoid that you can now winterize. It actually happens at above 30 degrees Fahrenheit. You can actually literally see the waxes form in the solvent, in the second dissolving of the cannabinoids. I put my bowl in ice water, and that's all it takes, and I can start seeing waxes form. So I'm actually reducing the energy requirement as well, because you don't have to freeze all this alcohol. You just need to freeze this little piece of alcohol. But I do have a double distillation in my process. So there's heat energy expended for the first distillation with the bulk alcohol, then the finalized distillation when you just have a little bit of alcohol left. And it's at that point where you're able to get rid of all the solvents. You can do a very effective purge with this little bit of material. You take that up to 250 degrees Fahrenheit and it decarbs. You can actually watch it. I have a graphic I can share, you can publish on Cheeba, of showing what the process is of distillation all the way to decarbing. Because once you've completed decarbing as your very last step, you're guaranteed to be free of all solvents. Because ethanol and isopropyl have a boiling point of 170, almost 180 degrees. And you're decarbing at 250. So what is that? That's 80 degrees difference. No solvent will stay in your material when it reaches 80 degrees over the boiling point. Okay, so you're in really good shape. That's how you have safety in your final product.
Okay. Thanks for that, Doug. We're out of time, but I just just in the last 30 seconds, some quick advice to people who want to try ethanol extraction at home. What's your 30-second advice?
I would say be safe, first and foremost, and use dry ice. Play around with a little bit of dry ice, and make sure that you're using food-grade ethanol that has not been denatured. Some of the denaturants that are put in the ethanol to stop people from drinking it can get left behind in your end extract and contaminate it that way. So yeah, play around with dry ice. I would recommend that.
Great, thanks for that, guys.
And
thank you so
don't put
much.
Dry ice directly into your solvent.
Obviously, this is a very deep topic and some incredible information that you guys have shared. So we really sincerely appreciate your time. Thanks so much. Thanks to House of Extractions for co-hosting this with us. Yeah, we look forward to seeing you on the international stage somewhere, sometime. Have a great evening, wherever you are. Thanks to everybody for watching. This was a presentation by Cheeba Cannabis Academy and House of Extractions on ethanol extraction. This will be on YouTube if you want to watch the rerun. And we look forward to seeing you next time. Thanks and have a good day.
So I think that was